Alright, now we're going to talk about compound interest. Notice how this formula starts with a letter A instead of a letter I. If we look at the list of what each letter means here that I've placed here for you, notice how A means the total amount, including interest. So if you remember back on our simple interest problems, we were finding the interest and then we were adding it in ourselves so that we would have the total amount. This time we don't have to do that. We actually get the total amount from the formula. But the flip side to that is if you actually just want the interest, you're going to have to now do subtraction from the original amount to the total amount later to find that interest. Okay, so we have P, which is the principal. We have R, which is the rate, but you always change it to a decimal. It's all pretty much always given to you as a percent, and you always want to give your answer as a percent, but you always use it as a decimal. T is the time in years, and N is the number of times the interest is compounded in a year. Now someone was interested, why does this formula have a random 1 in it? Well, that 1 represents 100%. So since the formula is giving us the total amount, the 1 is the total amount, like, of the principal, right? 1 times the principal. That gives us the starting amount. And then we add the interest to it. And the plus R over N to the NT power is what generates that interest amount. We're dividing by N because we're compounding it that many times a year. So say, for example, we're compounding it quarterly. That would be 4 times a year. And so we're taking the annual rate R and we're dividing it by 4. We're dividing it into 4 times a year to do the problem. Okay, let's go ahead and work through number 4. Suppose that $1,000 is invested at 8% interest compounded quarterly. How much is in the account at the end of 3 years? All right, so let's kind of figure out what each number means. So the 1,000 is P, the 8% is R, but we need to make sure we use 0.08. Quarterly is the number of compounding, so that's N equals 4, because that means it's happening 4 times a year. Some of the other words you might want to pay attention to are like annually would be N equals 1, semi-annually would be N equals 2, monthly would be N equals 12, weekly would be N equals 52, daily would be N equals 365, etc., right? How much is in the account at the end of 3 years? So that's T is 3. All right, let's plug everything into our formula. So the amount we're going to have, including interest at the end of this 3 years, is 1,000 times 1 plus 0.08 over 4. And then that's going to be to the 4 times 3 power, NT power. So your power is 12. Be very careful when typing this stuff in a calculator. You want to make sure you use lots of parentheses. In fact, I would insert parentheses right here, or just type that in as a 12 to begin with. Because if you type it in as a 4 and then times a 3, it might use 4 as the power and then just multiply the whole thing by 3, because the calculator won't know that both of those numbers are part of that power. All right, so I'm going to go ahead and put this in my calculator and see what I get. So I've got 1,000, I'm going to use a parenthesis, 1 plus 0.08 divided by 4, close parenthesis, to the 12th power. Since 4 times 3 is easy to do in my head, I'm just going to use that as my power. So that gave me 1,268. Since this is money, I recommend just rounding to the nearest cents. So $1,268.24. So the question is, how much is in the account at the end of the 3 years? That's our answer. Now, what if the question was, how much interest did we earn in that 3 years? How would we find that?
Sure, dividing by 1,000.
Perfect. Jocelyn? Okay, yes. Okay, we're going to type this problem into a calculator. I don't know how this will compare to whatever calculator you're using. So I'm typing in 1,000 for the principal, and then I'm going to use parentheses, type in 1 plus 0.08 over, so I'm using a division button, divided by 4. Then I need to close that parenthesis. So I've got 1 plus r over n, and then to the nt power. Now let's say that 3 times 4 was too big for us to do in our heads. That means we would want to use another set of parentheses with our 4 times 3 or 3 times 4, whatever, it doesn't matter what order it's in. So that the power is multiplying together in the parentheses before it's the power on this set of parentheses, before that whole thing multiplies times the 1000. So then we hit enter, and we get that result. All right, let's go through number 5. So amount would be equal to $1,000 times 1 plus 0.08 divided by 365 to the 365 times 3 power. If your calculator isn't giving you the right answer, you might consider trying to do this part first. So do all this first, and then multiply at the end. Multiply p at the end, because the order that we multiply in doesn't matter. So that way it won't mess with this number. That'll maybe be a little easier. Sometimes your calculator might need you to put parentheses here. Depends on how your calculator operates. Sometimes you might want to actually do these calculations separately. Like you could literally find each calculation and write it down as you go. So like if I wanted to do 0.08 divided by 365, what? My calculator gave me an error. Okay. Oh, let's talk about this too. Do you guys know what it means when your calculator says E has a little E with a -4? Do you guys know what that means? That means it's scientific notation. Yeah. So let's talk through that. Okay, I just did my 365 times 3 and I got 1095. So it's compounded every day, yeah. So this Okay, so do you see how I just started doing each piece separately and writing it down? That way, if your calculator is doing something wonky, you're not getting the right answer. If you do it piece by piece, then you know personally that you're doing things in the right order, even if you're not sure what order your calculator's doing things in, and that should help. So then when I add those together, I get 1.000219. You want to use as many decimal places as you can just to avoid rounding errors. But I know they get annoying to write down. So that's going to be to the 1095 power. And then I'm going to multiply that by 1,000. And I got 1271.21, although the 21 would round to a 22. Now something else you should stop and think about, which I think some of you already were, which is why you were asking me questions about it. And that is, does your answer seem reasonable? Look, our answer when we compounded monthly was 1268.24. And now compounding daily, that means we're earning more interest on our interest. We're just like $3 higher. Does that make sense? That the interest would be a little higher because it's compounding more often? Yeah. It should make sense that if it's compounding daily, it's earning interest every day, then you're going to be earning more interest on the interest, and the overall interest will be a little higher. A bank features a savings account that has an annual percentage rate of 3.4% with interest compounded quarterly. Ashley deposits $2,000 into the account. What equation can be used to determine the account balance after 2 years? So they want us to actually take the formula and put in the numbers we know for the equation and then use that equation in part B. So our compound interest formula would be the amount is equal to the principal, which is 2,000, times 1 plus the rate, so 0.034. Now here's where the rates start to get messy. When the rate is already a decimal, but it's a percent, and you have to change it to a decimal, you're still just moving the decimal place over 2 places to the left, but you still have to have the other decimal place that was on the percent, and so it would look something like this, if that makes sense. So then we're compounding quarterly, so that would be divided by 4, and then that would be to the 4 times t power. So there's the equation we would use. And if you wanted to simplify that a little bit, you could actually simplify this stuff in the middle. So I have that written down as well. So you could use a calculator to compute all of this. So according to what I have written down, it would be 1.0085. I don't know if anyone wants to do that 1 plus 0.034 divided by 4 in their calculator and make sure that you agree with that. So see, that just looks a little bit less messy. We've got a number we're multiplying by, we've got the base of our exponential, we've got the exponent. Otherwise, there's no other extra little pieces that we're going to have to put in the calculator and deal with, right? So there's our formula for this situation. Now we can use that formula to solve for 4 years simply by plugging in a 4 for t. So the value of the account will be 2,000 times 1.0085 to the 16th power, right? So 4 times 4 power, 16th power. I don't know why I wrote that way, but I did. Okay, so try that in your calculator. I don't know if any of you already did it. My calculator says that this would be $22.90 and 5 cents. Let's just kind of make a list really fast of what n would be for a few things. What if it says annually? What would that mean? Yeah, so n would equal 1, right? Semi-annually. I guess you could even do biannually, but that doesn't even, that would be every 2 years. Let's not do that. Okay, let's do quarterly. Or instead of saying these types of words, they might say every 3 months, and that would be quarterly, right? Or every 6 months. And that would be n equals 4. Okay, you could do monthly, which would be n equals 12, and that would be 12 months, right? I don't think we need that at this point because you guys understand that that's what monthly means. Okay, so then how about daily? Daily would be 365. I don't know if they would do weekly. What if they did weekly? How would you do hourly?
24 times 365.
Yeah. Which is, I don't either. The number of hours in a year? Exactly, I know that one. Okay, we don't even have to do the math for that one. What is it again? 525,600 minutes. Now I really want to do the math and see if that actually works. Times 60. Oh, it does. Cool. Yep. All right, so there's some helpers for you depending on what numbers or things you get in your problems. So you've got 8 homework problems total. I think that'll kill you. Just